Pipehenge is known after the... Does anybody know anything about another thing that's got henge in it at all? What was it? What was Stonehenge? Now Stonehenge is a place in England where the stones are as big as buses, and they're arranged, and people used to think it was done for astronomy. And what we've got, this is Pipehenge, but this does the same thing, but it's actually made out of pipes. Now, there's going to be some very interesting things we'll discover about Pipehenge today. And the first thing to do is Pipehenge has got some labels. All the pipes have got names. So, someone has got them to start with?
Navigator seat.
Who's got the navigator seat? Oh, we better get the navigator seat. Someone's got a label? Got a navigator seat. Right, bring it over. And who's got the next one?
The next one is north.
Right, and the next one? Thank you. North. Who's got the next one?
East.
All right, keep them going. Right. Then what's the next?
0 degrees.
Now, so we've got a whole lot of labels. 0 degrees, that's an interesting one.
90 degrees.
And what comes after that? 90 degrees.
And then...
Then what? And the next one.
180, then 300, 180.
So,
180 degrees.
get your labels.
Now it's 270. Now it's 300.
So, hang on. You've got one of these labels got numbers, 360. Can you do it? Anybody do a 360 on their skateboard?
Yes.
What about their bike? Okay, when you do a 360, what does it mean?
Turn around.
You do a whole circle. So, okay, if you do a whole circle with Pipehenge, you can do a 360. Right, what's next, dear?
Circle.
Okay, well, this is pretty obvious. This is the circle. Something very special about the circle, because this really is like an observatory, and that's where you'd find the Southern Cross. It goes round inside that circle. Someone's got another one. Okay, now the ring in the middle here is actually the point around which the Earth turns. And this is very interesting because Pipehenge is a view of the Earth from the southern hemisphere. So that's the point around which the Earth actually turns in the south. What's next?
Star bars.
And get the next one as well. Keep going.
Tropical cactus.
Who's got the star bars? Bring the people who bring them out then. Bring them out to me, please.
No, tropical cactus. Oh no, yeah, tropical cactus.
These star bars, they are the ones in the south over which the pipes go. Tropic of Capricorn. This is this one here. So then, and this is the summertime, summer arc. Summer solstice. Who's got the summer solstice one? Great.
Meridian.
Now if I can just stop at that, because Pipehenge is actually a globe of the Earth. And it's from the southern hemisphere. So this point here is that point there around which the Earth turns. And what we're doing here just now, it's because the globe of the Earth, that part there is the Tropic of Capricorn. That's this one. And Pipehenge was made on a line through the North Pole to the South Pole through Carey Park. Every place on the Earth has got a line from the North Pole to the South Pole through it. Every place. And we discovered that this line here was the line from the North Pole to the South Pole through Carey Park. The interesting point, it's the true North Pole and the true South Pole around which the Earth turns. Does anybody know another pole at all? What do you think it might be?
The magnet.
Yes, the magnetic pole. Now, if you get a magnetic compass, you find it's got north and south and everything on it as well. But that's the magnetic north and the magnetic south pole. And the magnetic north,
Is that where the green and the...
it's not in here at all. It's in northern Canada. And the south pole is not, the south magnetic pole is not here. It's a little way off from the south pole. So the magnet points to the magnetic pole, but this one is set to the true north and south. So that's that part of it. Now let's have a look at this one. The interesting point is that when Pipehenge was put in here, it was made especially for Carey Park. And that line there is the length of daylight in the middle of summertime. And that's where the sun rises, and that's where the sun sets, and that's where it's in the middle of the day. Now, that says summer arc. Someone got one for this one that says winter arc. Come on then, please. And it also has some other names. It's the Tropic of Cancer. And it's called the winter solstice. And it's got a special date. It's June. This one is in June. And this one is in December. So that's the length of daylight at Carey Park in the middle of winter. See, it's pretty short, isn't it? Yeah. And this one here, much longer days in the middle of summer. Right, what's the next one, dear?
Meridian.
The meridian. Now, this is an interesting point here. This point is the meridian, and you notice it goes from the North Pole across the top down to the South Pole. Now, I wonder, does anybody know where the sun is right now? If it's on a clock, what would you say the sun is now? Is it in the morning or the afternoon?
Morning.
Now, in the morning, there's a couple of letters that tell you when it's morning. What is it?
AM.
AM. So if I put A and M, what do you think the M stands for?
Meridian.
Oh, good on you, meridian. Now, that's a funny word. It says ante or before, so we spell it A-N-T-E. But if you're going to the afternoon, what's it for then? Yes? Yes? That's before meridian is ante. What about afterwards?
Past.
Past or post. We have P. It's in actual fact, it's an interesting word. It says post, and meridian comes into it as well. Would you like to sit on the seat there for a moment? Whereabouts the sun, can you see where the sun is? It's on this side. It is before the meridian. Okay? If you come here in the afternoon, which side would you think it would be on? It'll be on that side. It's past the meridian. And the interesting point for this one, when it's on the meridian, it's noon at Carey Park. And noon today at Carey Park is not noon by your watch, it's noon by the sun. And it's 9 minutes past 1 today. The sun will be right north of us, and all the shadows will be pointing to the South Pole. Now you'll notice that while I've been here, I've been just putting a record down here, and I put down a little while ago, I put the shadow was at 11:50. It's now on 12 o'clock. Now it's 12 o'clock right throughout the whole of New Zealand now, right? Noon, but not at Carey Park. It's 12 o'clock here, right? But not 12 o'clock, not noon by the sun. So that's that one there now. And I'll put there, that's 12. It's now on noon. Now, we've got some more labels. Any other labels? Come on, please.
Horizon.
Come on there. Horizon. Okay, this is the horizon here. That's the eastern horizon, and that one is the western horizon. Now, the interesting point here is that a lot of people think that the sun rises in the east and it sets in the west. It only does that twice a year. It does it from where you're sitting there. It does it on March the 21st and September the 23rd. You'll notice that the horizon is half black and half white. So during the summertime we have long days and short nights. But during the winter time we have long nights and short days. Right, now where that horizon is black, that's where the sun rises and the days are shorter than the nights. And this one here where the days are longer than the nights. So today the sun rose up about here somewhere. And here's a point. That point there is December the 21st. And that point there is June the 21st. How many months between December and June do you think? What do you think it is? It's 6 months. No, it's half a year. Yeah, this pipe is 6 months long. It's a year folded in half, and this one is 6 months long as well. So in the middle of the winter, the sun rises here. In the middle of the summer, the sun rises up there. So thank you. Have you got any more labels? No. Okay. Thanks, Ron. Who's got card number 2? Come on then. What's card number 2 say? You've got to place the seat. And there was a job that had to be done with it, and that was to put some string out, wasn't it?
Yeah.
Okay, grab a hold of that and just hold it there. Hold it there. Right, keep a good hold tight. I'll just take this out of the way. We'll put it around the bottom of this one, and we'll put it around the bottom of this one, and we'll take it right across and put it around the bottom of that one. Put it down right down the bottom. Dear, put it on the ground. Good. Now, when Pipehenge was being designed, people had to say, well, where do you sit for it? So it was put right in the middle of it like that. And this pipe is called the navigator's seat. Does anybody know what a navigator does? Yes, dear.
It shows you where to go.
Yes, how to find your way. Well, this is how do we find our way with the Pipehenge. Now, see what can you notice what's on what are the letters that are around there?
Northeast.
Starting with N and
East.
and W. What does N, E, S and W say? Yes?
Northeast, southwest.
Yes, north, east, south and west. Has anybody got a saying to help? Yes?
Never eat soggy wheat.
Never eat soggy wheat bix. What another one?
Never ever smash windows.
No, never ever smash windows. Yes?
Never eat slimy work.
Oh, goodness me, there's lots of things, isn't it? So, the interesting point there is they go around in that sort of a line. So, that's where the navigator's seat goes. Would you like to come and sit on it, please? You leave that, Christina. Yep, come and sit there. Now, the idea was, when a person's sitting on the navigator's seat, their eyes are level with the horizon frames. Because, in actual fact, Pipehenge is just like a great big observatory or a spaceship. So, you are looking out into space between that bar, and that's where you find the sun. All the year goes all between those two bars. But so do the planets. The planets are also between those two bars. And so the moon is always between those two bars. And the signs of the zodiac, the planes there are always between those two bars. And that's looking out into space. So at night time, this becomes an observatory. Now, would you like to turn around this way and look out here? And if you put your fingers and thumbs around your face like that, it makes that circle.
Oh, yeah, it does.
Okay? So you've got to be sitting on the seat there to find that circle. I'm going to do some more about that a little bit later on. Right, away you go. And who's got the next card? What is it, dear? And what does it say?
To read off the compass degrees around the seat.
Okay, if we just go to the compass degrees around here, what does it start with?
N.
And what's the number?
10.
Big and loud.
10.
10 and
20.
and
30.
and
40.
and it goes on right on round to what does it come up to at the end?
350.
And it comes right back to 360 right round through there. And you notice it goes clockwise around the seat. Now, what else have you got to do there, dear, on that one?
That's all.
Okay, let's have a look at this just for a moment. Yeah, so they're just all the degrees, isn't it, from going from circle, going around like that one. Great. Now, it's the true North Pole and not the magnetic North Pole that this is sitting on. Okay, who's got the next card? Righto, what's your one say? It is a? It's the globe of the Earth, right. Now, I said that just a moment ago, didn't I, when I held the globe up like this. That was the Tropic of Cancer, that's the Tropic of Capricorn. This is the northern part, and this is the southern part. Now, the interesting point here, and maybe, if I just get my ball, and this was, somebody said to me, does anybody know what the shape of that ball is?
Round. Yeah.
Well, it's round. What else is it? It's also,
Sphere.
it's
Square.
a square.
Sphere.
A sphere. Oh, it's a sphere. Now, can you point to the top?
There is no top.
There is no top. Okay. Well, I suppose if you might say that's the top, I can turn that's the top, and this is the top. So, if the globe of the Earth is a sphere, does it have a top?
No. Yes.
Yes. Well, some people think north's at the top. Well, we're in the southern hemisphere, so we can turn it round like a sphere, and if you like, the south can be at the top. And that's the way we see things in the southern hemisphere. We look out into space from the southern hemisphere. Yes, dear.
Does the Pipehenge have the equator line?
Yes. Well, the equator it would actually have a line from here across there and down to there. Now, I put a label on here that said equinox, and that's equal day and equal night. So we've got daylight saving just now, but at June, in March the 21st and September the 23rd, the sun rises on east and it sets on west, and it goes through the middle of the Pipehenge down like that, as if it was going across on the equator. Right, what's the next one? Who's got the next card? What have you got there? Oh, it's the Pipehenge. Now, does somebody have a watch? A watch? You got a watch there? Can you time 8 minutes for me? Has you got a stopwatch? Yes. Okay. Now, tell me when I'm ready to go, and I'm going to clap my hands. You ready? Got it started? Now we're going for 8 minutes. When it comes to 7 minutes and 40 seconds, can you say stop? Because I want everybody to count down the last 20 seconds, because something in 8 minutes time, something really amazing is going to happen, and you're timing it. Right? Now, what else have we got? What's the clock? Now, because this is sort of on the earth, and we find that the shadow lines are gradually moving. They seem to be moving from there, and they seem to be moving across like that. This is like the minute hand of a clock. And if you look down there, you see we started off at 11:50, and 10 minutes later we had it at 12. When the sun just comes out again, we'll do another line there as well, and we'll just see what happens there. What else have we got to do with that one?
Card 6.
Oh, card 6. Who's got card 6? That was timing sunlight, wasn't it? Yes. So we'll come back to that in just a moment or two, because he's timing us. How many minutes have gone so far?
1 minute.
1 minute. So we've got a little bit more to go yet. So what else have we got here to do? Now, okay, you can sit down there. Why do you think the line seems to be moving? What do you think's doing that? What do you think's doing that? What do you think it is, dear? Okay, some say, well, the sun's going across the sky. You can see that. You don't you agree? What do you think it is?
It's the earth moving.
Ah, so hang on a minute. She says the sun's going across the sky, and you say the earth's moving. I think you're both right, because if you were like people from Henderson Valley School, and you could look outside and you can see the sun sort of going across the sky. But if you're an astronaut sitting out on the space station, you'd say, no, it's not the sun going across the sky, it's the earth turning. So what is it?
It's really both of them.
It's really both of them, and we've got to hold those in our mind at the same time. But everybody says the sun's going across the sky. That's what we just think it is. But in actual fact, it's the earth that's turning. And what we're happening here, the Pipehenge, in actual fact, is timing the turning of the earth. And we are recording it down here. So as
12 hours we did that.
well, we can. What is it there?
12 hours.
Yeah, well, we can do it for about 12 hours, only while the sun's up, of course. A bit hard to do it at night, but it's still going. Now, at night time, we see the stars actually going round the side here. So this is a big clock as well. And if you're looking out for the Southern Cross is down here tonight, and it gradually moves around inside that circle. Right, what's the next card?
7.
Who've got number 7? What's yours?
Oh, it's number 6.
What is it?
Number 6.
Can you bring it out?
It's the timing.
Oh, timing sunlight. We're going to be waiting for that in just a moment. How are you getting on?
It's been 3 minutes.
3 minutes. Okay. Who's got number 7?
Me.
What is it now? Oh, the meridian pipe. Now, you can sit down here. We are talking about this being the M of meridian. That's the line that goes over the top. This is the AM side, and that's the PM side. But if we take the globe of the Earth, you'll notice that there are lines from the North Pole to the South Pole all the way round. And I've put a green line down here that goes just off the coast of New Zealand. And these lines, there's actually 24 of those lines. They run from the North Pole to the South Pole. Does anybody know what those lines might be called? What do you think, dear? They're called meridian lines. Okay, that's it. And we've got one just off New Zealand, where New Zealand that's where the day starts, just off New Zealand, just off the Chatham Islands. So everybody on this side is having Wednesday, and everyone on that side still having Tuesday, because it's that's where the new day starts just off the coast of New Zealand. And so those meridian lines, and there are 24 of them, and they are an hour apart, because it takes how many hours for the Earth to turn once? What is it? 24 hours. So that's what. So Australia, Sydney is 2 hours behind New Zealand. Well, they're always behind New Zealand. So, and then further across, Perth is about 4 hours behind New Zealand. So it takes a little while for the Earth to actually turn that part, but it's the Earth that's doing the turning that makes it look as if the time is going past. Right, has somebody got another card? What have we got there, dear? Oh yes, you notice over here, this is interesting because the children who developed this were in year 6 or year 8 classes, and they sort of thought of all the colours, and they thought this one, which was the North Pipe, it was the hot end, so they did it red. Well, it was easy enough to do this end.
Blue.
And what was blue for? It was cold, so that was the cold end. But when they came to this one, they said, now, I wonder what could be best for the east. What do you think it might be? Yes. Now, that was very interesting, because the people were down here. When the people were doing this, one of the girls had a boat, and she said, Mr. Jackson, the lights on the side of our boat are green on that side, and it's called starboard.
Oh, yeah.
It's okay. So that was the starboard side. So they painted it green. But somebody said, yes, but I think it could be a better one. If you look around you, what's the most important colour?
Green.
Now, if you took a sack or something like that and you put it over the grass, what happens to the grass underneath it?
Yellow.
Why?
Because it doesn't get any sun.
It doesn't get any sun. So when the sun comes up each day, it keeps the grass green, right? And so they said, well, it comes up along the eastern side, so because it comes up every day, it keeps the grass green. So that's another reason why that's green. But this one was a really hard one, because from where you're sitting there, this would be port, and on a boat on this side has a red light, but we've used it there. So they thought, well, what colour could we make the western side?
Yellow.
Oh yeah, they did.
The sun.
Oh yes, because as you look down on the western side, you see the sun going down and the clouds get reddish or orange or golden. And so that's why the western side was coloured yellow. So that's that. Now, we found out that why this is half black and half white, and this one over the top was white because that's the meridian line. What else you got there, dear?
Sunny day. Purple marker there.
Right. Okay, so if you can just pop on back, because, oh, that's the sun just coming back out here again. All right, not quite. I have to wait for a moment. Right, who's got the next card? Card. How's the time?
Few more seconds.
Few more seconds. How many?
About, I don't know, 10.
Okay, again. 19, 18, 17, 16, 15, 14, 13, 12, 11, 10, ready? 9, 8, 7, 6, 5, 4, 3, 2.
1.
Look around and tell me something that you see.
The sun's right up in the middle of the sky.
Tell me something else that you see.
It's not that.
Can you see the car there?
Yeah.
Can you see the trees there? Can you see the clouds up there?
Oh, it's windy.
Can you see any birds?
No.
No. Okay, why can you see the trees? Why can you see the clouds? Why can you see the card? And why can you see me?
This morning. Because it's afternoon. Because of the brightness of the sun makes it so we see things.
Where do you think the light came from?
The sun.
How long did it take to get here?
12 hours. 7 minutes. 12 hours.
We've just counted how many minutes? 8 minutes from the time I clapped my hands and you started, and he counted down 8 minutes on his watch. And when I clapped my hands first, the light left the sun, and it's just come 150 million kilometres.
Whoa.
And how long did it take here?
8 minutes.
8 minutes. So that is the speed of light. Now here's the very, very interesting point of why I have spent like that, because tonight I'll show you where you can find a star. The light left there 4 years ago, and it's been coming here for 4 years. Now, this is some maths for you. Can you work out how old were you 4 years ago? That's 4 years off your age now. What do you think?
6.
You were 6. What were you?
I was 7.
7. What were you? What was it?
6.
6. Right, when you were 6, the light left Alpha Centauri, which is one of the points of the Southern Cross, and it's come for 4 years, and it's going to arrive here tonight. Now, how old will you be in 4 years' time? How old will you be?
15.
15. What about you? 15. What about you?
14.
14, yes?
15.
Okay, now, on your 15th birthday, I'll tell you something you can do. You can say to the people on your birthday, I want to show you something that's really, 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 really special. Come outside. Do you see up in the Southern Cross up there, that bright star is called Alpha Centauri. And it left there on November the 30th in 2011, and it's been going for 4 years, and it's arriving here tonight. So when you're having your 15th birthday, you can say, I was at Henderson Valley School and we were sitting at Pipehenge and I timed the light travelling from the sun. That's pretty smart, isn't it? So the light's leaving there tonight is going to take 4 years to get here. Now, how can you find that out? Do you remember what I said about this, the time of solar noon today? What time was it? Do you remember? What was the time after 1 o'clock? Yes? 9 minutes past 1, right?
Yeah.
Now, it's 9 minutes past 1 at your place at the weekend. Right? Now, I'm suggesting, this is something you can all have a go at this. Would you like to come here a minute? Just leave you put your card down. Now, what time is it going to be on Saturday? 9 minutes past?
1.
9 minutes past 1. At 9 minutes past 1, go and stand at your side and put a stick down like that. Come and sit around here. Stand here and look this way. Come around here. Looking like that. Right. 9 minutes past 1 at your place. And you people, 9 minutes past 1. Your shadow will be pointing off to the South Pole. Put a stick like that along your shadow, because which way does that point?
North.
Yes, and which way does this point?
South.
South. Now, if you turn this way, turn around here, turn around, and put your hand out there, which is that direction pointing?
East.
Okay, and he puts his hand out there, what's that direction pointing? West. So he's now a compass. And if he brings his hand across his hand like that, around here, around here, around here, around here, around here, around here, like that, he's just done what I would do inside here, from that side, across there to that side. What do you find in that band?
Sun.
The sun and
Sun.
the planets and the moon and the constellations and the zodiac one. So, if you do this at night time this weekend and you come out, like do that in the middle of the day, isn't it? What time was it? 9 minutes past 1, right? And if he does that in the middle of the day and then come out just as it's getting dark and puts his hand out like that and puts his hand across like that and looks up over there, he'll find that that's Jupiter, that bright star over there is Jupiter. And other ones along here, the other bright ones along there may be planets. The moon might be there as well. Now, if you come around this way, this is a really, really, really special one, and put your fingers and thumbs around your face like that, looking at me, and looking back out this way, what happens now is, what do you think is going to be inside his hands? What do you think it's going to be? What do you think?
The moon.
No, look, you're looking this way now. Yes.
The southern.
Come here a minute. Sitting down on there. And if you put your hands around your face like that, what is it? That's the circle. What's inside here?
The
Southern Cross. So if he's standing there and he's looking up like that, what do you think is going to be inside his hands? The Southern Cross. Now, as you look at that, it's just getting dark. you look up there and you'll see the Southern Cross is up there. The very brightest star up there is called Alpha Centauri. The first star, Alpha Centauri. How long ago did the light leave Alpha Centauri before it comes to New Zealand, come down here? 4 years. Right, can you sit down now? Okay, so it takes 4 years. So what we're going to do, we use Pipehenge here, put some ideas in our mind, take it home, and we can find those things at home. Right, who's got the next card? 8. And what have you got there? Okay, come and sit on the seat. Hang on to your card. Right, we said earlier that Pipehenge is like a spaceship. This is the windscreen of the spaceship. That's the bottom of the windscreen, and that's the top of the windscreen, and you're an astronaut. Okay, so she's the pilot of a spaceship. But the interesting point, did you bring anything to eat with you? You haven't. Well, you better turn around this way, because this is the boot of your spaceship, if you like. We're going to open this up, and this is where we can put our goods. But this being like a big observatory, when we look back through here, that's the stars that actually go round and round and round inside that circle. And that's the point. Remember that point where it was? That was the point around which the Earth turned. Now, if you turn it this other way and looking back through our windscreen again, it's as if we've just got sitting into our big spaceship. This is where the sun and this is where we're going to find the sun and the stars and the planets are moving here, and they seem to move across the sky in that part across our windscreen. And your eyes are just level with the horizon frames. So you're a Miss Astronaut. So Pipehenge is actually like a big observatory. Now at night, during the daytime, of course, this is where the sun's found. But during the night time, this becomes actually an observatory to be able to see those sort of things. Now the interesting one here at Carey Park at night time, this is where you find well, you can find the moon, but this is where you'll find some of the satellites go orbiting through the skin here. So you can see the satellites moving through here at night time. Okay, yes dear.
If you're at home, how can you tell which way is south and which way is
How can you find which way is south? You just know when solar noon is, 9 minutes past 1 on Saturday. And if you come on here then, you stand on this there. I just bought a broom handle from home, but you can get a broom handle, or maybe draw some chalk on the driveway. But if you can mark it like that, something like that, 9 minutes past 1, and put that mark down. Which direction's that?
South.
South, and which direction's that? North. So that's how you can find north and south through your place. In fact, anybody.
It doesn't depend which way the shadow's going.
The shadow at 9 minutes past 1, anywhere around Auckland. At 9 minutes past 1, the shadow points to the South Pole. Whether you're living on the North Shore or East Auckland, it's 9 minutes past 1. Different place, different for other places in New Zealand.
So it'd be cool if you could paint a line.
You could paint a line on it, yes, yes. In fact,
forever.
that would be an idea even at the school. If you'd like to paint a line on the playground at school, you can have a line, a north-south line through your school. Right, what's the next one? What is it? That's the observatory. Righto, now we've just done the observatory one, looking at the what you can. This can be like an observatory as well. Right. You have, right. Well, that finishes our cards, doesn't it? Oh, yeah. What's your one? 10, is it? Okay. It says what's in the sky tonight. Well, that's pretty good, because you can find out what's in the sky tonight. I have to cut break for a moment. Now, just before I came, I went on my computer and I looked at sky maps. You can do this yourself. Can you bring that here, please? I went on the internet and went www.skymaps.com, and I printed out a sky map for us for today, or for December. So this is what is going to be. Well, you can now use a little sky map like this to find your way around the sky, and it has a line that comes across it, which is the line of Pipehenge on it. And so you can use this, and to use it, of course, you've got to hold it above your head with north up there. And if you're looking at the south, you've got to hold it above your head with south in there. And it tells you what's actually in the sky. So that makes your Pipehenge an observatory and what's in the sky tonight.